Hi, welcome back to another episode of the Weld.com podcast, where each week we explore different pathways available in the welding industry. I'm your host, Bo Wickington, and today we're at Prima Power LASERDYNE, and I'm talking with Mason Bongers, an application engineer here. Mason, how are you, my friend?
I'm doing quite well today.
So, Mason, how did you first get involved in lasers?
Well, I graduated as a mechanical engineer. Got sick of, and after working there for a couple of years, got sick of working at a desk, sitting down all day, just working on a computer. I want to do something with my hands. So I came across this job, able to do welding, able to do cutting, drilling, coding with my hands, talking with different people here and there. Seemed like a perfect job for me.
What kind of training did you have to go through when it came to lasers?
So to become an application engineer, it's about a 4-month period of learning all the NC coding. A machinist will be comfortable with NC code, getting used to how you're changing parameters. You change power, you change feed rate, you change your gas flow. What does that look like when you're talking about a weld? Getting used to terminology here. I didn't come from a welding background, so it took me a bit longer to get used to how welds work.
What was the most confusing part about learning about welding?
I think for me, the thing that got the most confusing, or the thing that was just most surprising to me, was gas flow is incredibly important to laser welding. I've done some welds where, I'm changing things every single time. It just looks terrible. And I change the gas flow a little bit, boop, perfect weld.
Yeah, gas is very important. You don't really think about it. I know a bunch of people out there first getting into welding. There's a lot of parameters you got to keep track of when you're trying to make a good weld. And with laser welding, let's talk about the gas. What kind of gas do you typically use when you're doing welds with the lasers?
So usually we'll use nitrogen. It's cheap, easily available. Most people can install a generator on their shop. Otherwise we use argon. A little bit more expensive, but does a little better coverage.
When you go to set up a weld, because this is way intense. We're not doing it by hand, and this is a lot of power that you're working with. So how do you go about determining how much power you need to put into a weld?
Well, the power is the easy part. If I'm not getting through, more power. If I'm getting burns on my weld, if the top side's looking a little crispy, drop back the power.
Well, and we have different types of power too. You got the quasi and constant. Can you explain the two different types of lasers?
Sure. So quasi-continuous wave, QCW lasers, those are lasers that they can go peak up to 10 times the power of a continuous laser. And so the laser we're sitting in right now, this is a 1200 watt QCW, which means it can pulse up to 10 times the amount, so 12,000 watts. Most of the time for welding, we're using CW mode, which is just turn the power on at a commanded power, so 2,000 watts. And you just turn the power on, it'll just run at that power. When we start talking about pulse mode, that you start talking a little bit more about different parameters. So how long it's on for. So you have to command a certain amount of time that's pulsing for. How many times per second are you pulsing? We'll run it 200 times per second. Turning on, turning off, turning on, turning off. And then, of course, your peak power. So you're turning it on. How high do you go?
So you said 12,000 watts. What is the kind of high end of the most wattage you could put into one of these lasers?
Yep. So here in this facility, we've had a 30 kilowatt machine, so 30,000 watts.
That's a lot of beans.
That's a lot of beans, yeah. Most of our standard lasers, they come up to a 23 kilowatt machine, or QCW. So it's 2,300 watts of average power, but you can pulse up to 23,000 watts. We're working on a machine right now that's able to run at continuous wave 10,000 watts.
What are some of the projects you've used that high power on?
Yeah, so one of our latest ones is Project Vulcan. So this was specifically developed to compete with E-beam.
Not that kind of Vulcan, right?
Not that kind of Vulcan, no.
Okay.
Vulcan is in the Roman god of the furnace.
Oh.
And so this is made to compete with the E-beam, so 10,000 watt laser. Right now, anything above 6,000 watts, CW is usually done on a robot. We decided to do it with a 3-axis system. More in our case, we've got 5. This is meant to, nice and stable welds. You don't have any kind of vibration coming into your melt pool. And so we've developed a 10,000 watt laser to be used with a machine head with active cooling. So we'll run water lines to the mirrors to cool them down. We've come up with a high power welding nozzle to cool, trailing after the weld itself, because your weld is so hot that if you don't cool 5 inches after your laser beam hits the material, it'll oxidize. We've come up with a wobble head. So it's a series of mirrors that will wobble back and forth at different frequencies to make a different shape. So like a figure 8 pattern or an infinity pattern, circle, even just a small line to widen your weld out.
Where can people find out about that? Or is it still kind of hush-hush?
It's actually being released right now. So, if you're interested more in that, I'd talk with the LaserDyne sales team.
What thickness are you even wanting to use that on?
I've done some welds through 3/4 inch thick steel.
That's some pretty thick stuff. We don't only just weld with these lasers. What all can these lasers do outside of welding?
So welding's our newest industry we're trying to break into, but drilling was our primary main staple until the last few years.
And by drilling, I mean, most people, when you think drilling, we're thinking either like drilling down into the ground or, drilling holes. Like, what kind of drilling are you doing with the laser?
When you're talking about drilling with these lasers, it's a lot of aerospace drilling. So when you talk about planes flying over your head, a lot of the drilling the holes in those combustors that make the planes fly, doing these blade and vanes, part of the combustor that makes the engine run, things like that. That's really small, tiny holes. I mean, you're talking 1 millimeter thick, 0.5 millimeter diameter holes that you're trying to drill through 20 millimeters of material.
If I want to set up something, I want to drill 10,000 holes in it, how long does it typically take you to dial in a part for a customer?
Well, if a customer sends us a part and they say, hey, can you make this part for me? It'll take me anywhere between a day to 3 days to get it all programmed up, fixture it properly, and then running the part. So 10,000 holes, I generally run the part about 50 hertz. So 50 holes per second.
That's a lot of holes.
That's a lot of holes per second.
Well, and you showed me a little bit of the drilling when it comes to holes yesterday, where, you'll make that initial hole and then you come back in and clean it up. So, can you tell people a little bit about that process?
When you fire a hole with a laser, what happens is a lot of the initial force, when you hit something with a laser, it wants to bounce back at you because there's no hole drilled through it yet. And so what happens is your hole looks a little bit like a triangle. It's very tapered. The entry side where the laser hits the surface, that hole may be double the size of the exit side. And so, we talked a little bit about if you do 2 shots per hole, 3 shots per hole, what that does is it straightens out that hole, makes it look like a hole,
Just like a regular hole.
Parallel lines.
For somebody that doesn't have any experience in either welding or lasers, what is your advice for getting into the industry?
It's a growing industry, and machines like this need operators. This isn't an unskilled position where you're just pressing a button and letting it run. We need people that are able to run the machines and able to look at the welds, look at the holes, look at the cuts and say, this is a good cut, this is a bad cut, let's change this right here. It's difficult to run a program. When I'm running one of these, it takes me a couple days to set up a program so it works properly. So if someone's interested in getting into the industry, go and find someplace. It's growing right now.
What would you say to somebody that's afraid of programming a robot?
Go slow.
Go slow.
Go slow. Don't fire the laser. I mean, when I'm running it, I run 6 times usually. Slow, faster, 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 then top speed, and then I'll turn on the laser.
Are there any good resources outside of training at your job? Is there any other things that you use to learn more about lasers and programming and all that kind of stuff?
Well, this is traditional NC programming, so many machinists will be familiar with it. We do have different locations on our website, also the LaserDyne YouTube channel. We have some videos on there we're regularly posting. Otherwise, research papers. I do a lot of researching in there, looking at academic research papers for one study, 2013, where they did with a fiber laser doing some welding.
What is the thing you like the most about your job?
I like the interconnection between being able to do something technical and talk with people. I get to come here, talk with you, talk with different customers that are curious about this. I do a lot of training, how to use the machines. I also use the machines every day. So if a customer comes to me and has a question, I'm able to answer them. I really like that about it, where I don't have to push people off and say, well, I'm just a people person, so you have to go talk with the actual expert. I am the expert, but I can talk with people too.
That's cool, man. Well, I appreciate you talking with me and setting this laser up to do this cool dance.
Yeah, it's good talking with you.
I hope you're enjoying the podcast so far. And hey, if you are trying to learn some new welding skills, but don't know exactly where to start, that's why we partnered with the American Welding Program. They have all kinds of different courses that are specific to each process to get you up and running as fast as possible on your own time. And being a listener of the podcast, you get 20% off if you use code WELD20 at checkout. Check out all the different courses they have available at AmericanWeldingProgram.org. Now, let's get back to the show. I am also here with Dallas Reed, another application engineer, but he had a little bit of a different pathway into working with lasers and everything. So Dallas, can you kind of introduce yourself to the audience a little bit?
Sure. As Bo said, my name's Dallas. I've kind of had a bit of a journey to get into laser welding and working at LASERDYNE, but it all kind of grew out of just an interest in manufacturing and growing from design and wanting to change things up. Starting at the beginning, I always loved telling this. 12 years old, started working on a farm for $1.85 an hour.
Woo.
Found out manual labor really wasn't my thing. So just kind of gradually grew up from there. Worked in fast food, worked at a hospital, tried college, didn't really enjoy it. So forced myself into the military, got them to pay for college, and then went back and graduated from the U of M with a degree in mechanical engineering and worked in a design and manufacturing company for a number of years in their current products engineering team. Then I took a job at a glass blowing company, and one of the new technologies that the owners had kind of been looking at was using lasers to cut through glass. As I kind of really took off with that, it kind of drove a passion in me to find another job that dealt more directly with lasers and kind of migrate out of the operations engineering world, which brought me to LASERDYNE.
The laser you were using at the glass company compared to these lasers, like what's the main difference?
1/10 the power.
Okay. Yeah, just little baby lasers compared.
Yeah, little baby lasers. They also use, rather than having a beam director head like this, where we have just single beam and point that it does, we use what's commonly known for like the marking and engraving industry as the galvo heads, galvo scan heads, where they have two mirrors in there that spin very high speeds. And I think we were looking at like 10,000 millimeters a second plus linear feed rate, or the equivalent of it as those mirrors spin around. Whereas we can achieve very high speeds with these machines, but we're talking maybe that speed in millimeters a minute, not millimeters a second. And the other big difference is that it wasn't a mobile 5-axis machining head like we have for this. It was a stationary galvo head that you just move up and down in the Z to change your focus.
In your last job, you were using it mainly for cutting. This one, you got a lot of welding applications you got to do. Did you have any welding experience before this job?
In school, I probably had about 15 minutes of welding experience. Woo. Another 15 minutes of like brazing, It was just like a real quick introduction. Hey, this is what you can do. But I did go through some weld training at previous jobs, just OJT, as we'll call it, with our manufacturing team. A lot of the times we have to, what they call design for manufacturing. We design a part, you need to make sure you people can make it. That's a big thing.
As far as like the welding that we've seen here, it's mainly autogenous welding, like no wire. So that's the main thing you do. Like the most of the welds, how big are the welds you're working with?
Kind of depends. I mean, we can have anywhere from like probably, say, a 32nd of an inch or a 16th of an inch wide. I think you might have saw some of those. The weld, very, very thin conduction welds. You can also get very thin keyhole welds, but it can really range. It just depends on the application and the desired outcome that people have for the parts, whether you want full penetration, more of a cosmetic weld. It can really vary, and we can do a lot. So,
overcoming a challenge as an engineer, you had to learn welding. right? So a lot of, there's the battle between engineers and welders. But if there are other engineers out there that want to learn about welding, like what's your advice about it?
Honestly, check out your guys' videos as a first step. Not
a paid endorsement.
But I started looking at your videos and found them pretty informative. I like the way you guys kind of break down the different industries, the different types of welding, tips and tricks, how-tos, what not to do. But outside of that, if you have a friend or know someone with a welder or want to check out a technical college, which is great, by the way, taking welding classes at Hennepin Tech here. It's always just a good way. You have to want to learn, I guess would say is the biggest thing. So if you want to learn, make the effort. Check out videos on YouTube. Mason had mentioned, check out some Google Scholar for educational papers that are published. I've even dug up some old published reports from the military. The Navy's got a ton on welding that they do.
Oh, the CBs, dude.
Yeah. CBs. I worked with them when I was in the military. So, yeah, it's just really cool. But the biggest thing is if you want to learn, you got to put yourself out there and start looking to see what's near you so you can learn.
A lot of people, they don't know the different things you can do with a laser. So, like, what applications might people be sleeping on?
It's got to be a material that's compatible with the laser, either the wavelength or able to couple with the material. Some things, all you're going to do is heat it up, but it's never going to, ablate the material or remove it or weld or, as they call, couple with it. But it's hard to say. Whenever I hear people like, oh, can we do this with the laser? I'm like, well, you say I can't, but I'm going to find a way to do it. So
right now, this is kind of comedic because we're doing a podcast from inside of a laser cell, right?
Yeah.
There's a pretty big laser.
And they don't even necessarily need to have enclosures. A lot of our systems that we sell are integrated into manufacturing lines that are open with, some kind of either protective room or protective walls around it that allow the larger parts and larger objects to be processed in there. So,
and like power wise, like what can I run this off? Like what kind of power do you need to usually run something like this?
We just have it plugged into 120 volt, I think. No, I'm kidding. Yeah.
I was like, whoa.
No, it's like 480 volts. Pretty spicy.
It's pretty spicy.
Yeah. You do need a lot of power for it. 120 is not what we run on.
Hey, man. Well, what is the most exciting thing that you have done at this job?
Being able to travel. It's always been something I enjoyed. Don't get a lot of opportunities to do so. But in my short time I've been at LASERDYNE, I've been over to Europe for a week and some change, able to check out a few different places on my trip back. I've also been all the way to the great state of Ohio, too.
Ooh, Ohio.
But no, in previous roles, I never traveled more than, maybe a city an hour away.
Yeah.
So all the traveling I had done was just on my own time, which, was fine. But being able to travel for work helps break up the monotony of always being in the same building or always being at your desk. Although in the roles I've had, I've always been one that's, out and around the manufacturing floor and avoiding the desk. But getting to see different places is always fun.
So if people, we've talked a lot about Prima Power LASERDYNE. If they want to learn more about it or they want to get more information on the different products y'all have, where should they go?
We'll have to drop that link.
We're going to drop it down. It's going to be down in the show notes for you.
But yeah, our website actually has a lot of really good information and papers and studies that we've done. Information people can learn from just to see what's possible for free, too.
It's free.
Yeah. I think we have a lot just about welding different thicknesses and materials, welding dissimilar metals. Our our bread and butter here is actually drilling. So welding is something we are getting more into the market for, but being able to drill smaller than 0.5 millimeter in diameter, and just thousands of them in different parts. So it's really cool to kind of see what can be done.
Well, cool. Well, I appreciate you. Appreciate you chatting with me, man.
I appreciate you having me on.
Thanks again for tuning in to another episode of Weld. If you're interested in learning more about Prima Power, go down to the show notes. We're going to have all those links there for you. I want to thank you all for tuning in. And until next time, we'll see you out there.